On this, I think this sentence, we'll see what happened. Yeah. Oh. Mm. Okay, this sentence is the core part of the problem, the idea of the problem. So what is the state of them? What is the state of this particular cord or elastic strings now? They are being elongated, no? Though they are elongated, but still what happened? That extension is negligible compared to their length. Fine, there's the thing. So what do you expect the length of them? Will all three will have same length or different length? So there are strings will give numbering for them. There's a 1, 2, and 3. Look at 1 and 3. They should have same length. And look at the 2. It should have different length. So let me give the number. This is 2, 1, and 3. Look at the 192. Or so 2 and 3 will have same length. So the length of them are different. So I'll first, this is the one equation, I'll write it. So that I'll be on safer side. So let L2, let this be L1. This is theta. So what is the equation now? Cos theta equal to L1 by L2. This is the idea of the problem. Lack of this, without this information, no way we can reach the end answer. Okay, there's a thing. Then the tension. So we'll calculate the tension. So here is the spring force will be acting. Call that as F2. Here F1 and this F3. As 2 and 3 are identical. So next, what is the condition? F2 is equal to, in fact, F3. Because 2 and 3 are identical, no? What about elongation? Can you say about the elongation? All three will have same elongation? No. It's need not. This one. So the elongation, I'll show the elongation the strings by red color strip. Huh? So compare the elongation. This will have elongation this much. And what about the elongation? Elongation here will be what is that green color, red color? That is the elongation, and that elongation is small compared to their length. I'm dropping further the perpendiculars also.
Sir?
Yeah.
Sir, when they are cut in equal manner. Sir. Are they cut in 3 equal parts?
He didn't say? 3 segments cut from a long elastic light cord are knotted at point P. The other ends of cords are attached to ceiling. He didn't say that equal parts, no? 3 equal segments cut. No, he just said segments. Fine. The sentence.
Okay.
Things are negligible. So,
draw one more triangle. So that the same thing. So that will be easy for you. If you can get this much, I think problem is over. It's very easy. You can see that. No.
Sir?
Sir.
I'll take out the video. Some problem is there.
Sir,
Yeah.
sir, why is the elongation in the second and the third segment perpendicular? Why is that angle?
So I'm taking that one. So here what happened? See, like when the block the moment I release no, so what happened? The strings what happened? The elastic cord they elongate. So here what happened? I am dropping a perpendicular here to get the relation between them.
Sir, how did you tell that the elongations are like that? I mean,
No, you look at that the diagram given. No, you look at the theta, the diagram. They're making an angle theta. So definitely what happened? The elongations will be different. And the relationship between them, I'm showing it here.
okay, sir,
Sir,
it will be different, but how did you drop a perpendicular exactly at the
I'm
end of elongation and all?
this one. You see that. So you mean to say why that triangle, right angle triangle?
Yes, sir.
Okay, that one. So let's come from here. So look at the uh, what is the all are of made up of same material, no? All are of same material. Then how the spring force and the elongation are related? Directly proportional. The spring force and the elongation are directly proportional. Okay, clear this one. So the elongation of both the strings depends upon the length also, because spring force depends upon the length. So look at the initial length of the cord. They are different, no? This one. The initial length of the cord are different. So therefore, though what happened, they're made up of same material, because of the different length, they will have different spring constant. And the spring force is proportional to what? The elongation. So based on that, what happened? So we are assuming that the elongations must be different here. So I'm just projecting it, that one. You can see that. So here actually, the moment I release it, both will elongate. So here it will be like this. Initially, let's say that they are relaxed here. So when I put when I suspend a particle, so what happens? The springs will come like this. This will be the situation. You're supposed to you didn't you not bother to analyze the problem. They're just looking at some mathematics here. This was the initial portion of the strings, no? So when I suspend a mass, what happened? It will descend. Got this? So if you look at the length now, so this was the thing, no? Are you getting the idea now? Okay, got this. This will be so. This was the position, no? So here, how much it got elongated? This much is what the elongation x2. This is what x1. Okay, it's not that to get the answer, I'm assuming the practically this what happens here.
So then the angle also changes, right?
But what he said, extensions are very small, no? I think you should like I highlighted that particular word, not
Okay, sir.
analyzing. Huh? Not analyzing. You have to look at really the English part, very important here. So F1, so F3 equal to F2, no? So therefore F1 plus 2F2 cos theta should be equal to mg. So there's a one equation. We have this one. So let's come for all are made up of same material. So they will have same Young's modulus. So then we'll try to write some relationship. This elastic constant, it is related to F1 by A, elongation in this X1 by L1. Similarly, F2 by A. Now there's the one formula related to Young's modulus and the force and this one. So as Hooke's law, what it says, stress directly proportional to strain. So what is this X1 by L1? X1 is elongation, L1 was length. So this will become strain. What is F1 by A? Will become stress directly proportional to strain. If I remove that, I'll get the elastic constant that I'll call Young's modulus. So how that stress and strain are related by this equation. So as all three are made up of same material, so therefore all will have same elastic constant. So now from this, F1 L1 by X1 equal to F2 L2 by X2. Okay, let's replace F1 and F2, some relationship what we have here. So what we have to calculate, find the tensile force T developed in the middle chord. We have to calculate F1. We have to calculate F1. So here F1 by L1, L2 equal to X2 by X1 equal to F. So what is X2 by X1 will become cos theta. F1 L1 by L2 cos theta equal to F2. This value and then any relationship, this one, cos theta, L1 by L2, what we can write? L1 by L2 is cos theta. So therefore, the next equation will be cos theta. This is cos theta, F2. So what is F2 equal to? F1 cos square theta. That will substitute here. F1 plus 2. F2 will be F1 cos square theta. This is cos theta. So what is F1 is equal to? Mg by 1 plus 2 cos cube theta. Okay, this will be what is asked here. Just this diagram is very important. This is what I actually have to come from here. Okay, I'll come to